my gosh,
This
it's actually
big,
pretty huge.
it's Optimus Prime.
Oh, okay. Hi, everybody, and welcome back to another podcast with Overmugged. So today I have a very special guest who's going to introduce himself. Can I get you to introduce yourself really quickly, please?
My name is Clarence, and I'm a AMF and EMF tutor at OVERMUGGED. So currently I teach Sec 2, Sec 3, and Sec 4 at Kovan and Tampines.
Nice. And speaking of O levels is coming up, and actually a lot of you guys have asked, if we're gonna do more content about O levels. So let's dive into it straight away. So today's video is called "The Only Way to A1" for AMF. So rightly, we have Teacher Clarence here with us, and let's talk about the trickiest topics of AMF and how exactly we can tackle it. Let's get into the details. Clarence, on to you.
I think the trickiest topic for AMF, the one that students struggle with the most, is Trigo. Because number one, Trigo is a very big chapter. Number two is a very big percentage on the paper itself. So for AMF, paper one, paper two combined together, total is about 180. And I can confidently say Trigo takes up about 30 marks. Thereabout, right, for every year's O level. So
A
it's a very
lot of
huge percentage.
actually.
Yeah, correct. And Trigo is something that students learn at the end of Sec 3. Some of them start off Sec 4. So it's not a very new topic compared to like differentiation and integration. So maybe they will struggle with it. So first thing why I say Trigo is a very tricky topic is because when it comes to solving Trigo ratios, right, which is the first portion of Trigo, right, essentially what we're working with is your Trigo ratios, which doesn't involve the use of calculator. But when the questions get a bit harder and a bit trickier and complex looking, students panic and they use the calculator. And straight away that will give you a zero, right? Even if your answer is
Why?
correct at the end of the day. Because the keyword in the question will always be without the use of calculator.
Oh,
Yeah. So
okay.
Trigo ratio is such that they give you like, for example, sine A is equals to 3 over 5.
Okay.
You have to find for me what is cosine A, right? So essentially it's called Trigo ratio because your answer must be in the form of a fraction, a ratio. But when students struggle, what they do is they will sign inverse, they will find for me the angle.
Oh.
And once you get an angle, then they will go and find for me the answer. But that's not what the question is asking for. The question don't want you to use calculator. Unless you can prove to me that you can get the angle without using calculator. But I have never seen a student done that before lah. And I don't think that's something that they are looking out for. So that's why students struggle with that. And I think the most important, or rather the hardest thing about Trigo ratio, other than the fact that students will use the calculator, is that when they incorporate double angle formulas, special identities, which what students will do is they will just divide the answer by 2. Like for example, if using the example I have just now, sine A is equals to 3 over 5. If now I'm asking you to find sine A over 2, students will just, since my angle divided by 2, my fraction will also divide by 2. But that's not how it works, right? We are supposed to use triple identities to answer this particular question, which is why I say it's a very tricky chapter. And on top of that, we have solving Trigo equations, right? And solving Trigo equations, the thing about Trigo equations is that number one, you have to do some sort of identity first, which is the proving stage. And to me, that is not the tricky part, because if you can't prove it, you can still make use of the information, which means it's not the end of the world if you can't do the proving portion. But when it comes to the equation portion, there is always a range given. So when there's a range given, there's maybe negative angle, maybe the angle can go up to 720, 360, etc. And that's when students struggle because they are not used to dealing with negative angle. It is part of the syllabus, but usually they are used to dealing with positive angles. And then once they're used to that, if I throw you a negative angle, you might panic, you might not know what to do. And then from there, you will miss out on a few potential solutions. So why I say few potential solutions is that because when I have a range given, my answer is not as simple as just what I see in the calculator or what I see after I do my ASTC or my 4 quadrants, right? Because with a new range, you can go maybe one more round, you can turn in the other direction whatsoever. So that's why students struggle. And the way to deal with a question like this, right? I always tell this to my class. When the question gives you a negative angle in my range, that's when you must remind yourself that you can turn in the other direction, which is the clockwise direction. So for those that do Trigo and you remember when it comes to solving Trigo equations, usually you turn in the anti-clockwise direction. That is positive angle. So if I see a negative angle, you will have to turn in the opposite direction into my clockwise direction, right? So that's when you start considering negative angle. And the last
There
part,
are negative angles. Like, what is this new thing? In our time, got negative angles, meh?
yes,
Really?
yeah, but it's not very commonly seen.
Okay, keep
But
going, keep going.
prelim questions, yeah, they'll probably test you on that because that's the best way to check whether a student understands trigo or not, right? And the last portion, trigo, there's trigo ratio, trigo identity, trigo equation, trigo graphs, right? Trigo graphs, to some students, it might be the easiest because it's just about drawing a graph, right? But when the values change, or when now, instead of giving you a positive equation, I give you a negative equation, that's when students panic because they are not used to seeing that once again, right? And that's when you have to decide whether you must fit the graph or not, right? So imagine your sine graph. Usually it looks like going up, then come down, right? But when I give you a negative sine graph, you must learn how to flip. So instead of going up, you go down first, then you go up. Yeah, so that's the tricky part, right? Because students will think that, oh, I'm used to remembering this shape, go up, then come down. Then if I change the question, they might not think that, oh, I must change the way my graph is drawn. So that's the tricky part, right? But of course, I've shared a lot of tips and tricks with my students on how to do with questions like this. Um, I'm not sure if I should be gatekeeping it or I should be sharing it to everybody, but all I can say is there is definitely a trick to it, right? And I will share it in the future, regardless on the channel or on Instagram or TikTok, right? So that's the first thing for Trigo. Second one is for integration, right? Integration is the second last chapter of the syllabus. And integration is a very big part. Just like Trigo, maybe it takes out about 20 to 30 marks per paper. And one application of integration is finding the area under the curve, right? So like I'll be given a curve, then I'll be asked to find the area below the curve, right? So the difficult part comes when the curve is now below the x-axis, which is number one, you have to realize that my curve is now negative. If I do the traditional method of integrating, your area will be negative, right? And I know some students, or rather most students, will realize that how can my area be negative, right? Because area is a positive value. How can it be negative? But in the exam, when students don't know what to do, they panic. They will leave the answer as negative, even though they know it doesn't make sense, right? And that's the difficult part, right? You must remember when to turn it into positive, and the best way is to throw a negative sign in front or apply a modular sign, right? But that's only level 1 of the difficulty. The trick now is when the shaded region is now not below the curve, because a lot of students will think that, oh, the area is always below the curve. But now if I were to give you a curve that is under the x-axis, below the curve means I'm not between the x-axis and the curve, right? So later we will plug in an image of what I'm talking about, right? But that's when students struggle because they need to remember that the area that I'm looking for is always between the x-axis and the curve. So it's not always below the curve, it's always between. So that's when students struggle. Like recently I conducted a quiz, or rather integration test with my class, right? Whereby the question is exactly what I said. The area that I'm looking for is between the curve and the x-axis, but students find the area below the curve instead, which is not what I'm looking for, right? So that is when students struggle. But the good news is, for O-level questions, right, for the past maybe 5-6 years, there's never a question that's below the x-axis. It's always above, right? Then that's easier for students to deal with because you can just think of it as below the curve, right? So that's easier. Hopefully this year's O-level is the same. If not, I'm a bit worried lah, okay? And of course, the last chapter that I think most students struggle with is kinematics, which is related to integration and differentiation. For students that take physics, this chapter should be quite simple, but for those that don't, they might struggle a bit because there's a this topic is very relatable to real life scenarios. What I'm looking for is my distance traveled, my velocity, or my acceleration whatsoever, right? But one new term, or rather one term that you need to understand is this thing called displacement, right? Whereby displacement is the distance measured from the initial position to the final position.
Oh, that one
Which means my question will always be phrased in such that I'm walking in a straight line, right? And I'm looking for the distance traveled. But what students forget is that if I change direction, I am now nearer to my, like for example, if I start at this chair, I walk towards the door towards my left, I stop, I turn back. So as I'm walking back towards my original seat, my displacement will go down. So what students will think is, oh, if my displacement is now 10, means the distance traveled is 10. But that's not the case, because I walk to the door, I stop, I turn back.
Okay, gotcha.
Yes. So my distance is actually not just 10. It's not just the displacement itself. You must consider for change in direction. You must consider whether I have stopped and turned back and then turned again potentially. So to deal with a question like this, right, I always tell my students to draw out the timeline. And before I draw the timeline, of course, I need to understand and find out when do I turn direction? When do I stop and change direction? And from there, once I draw the timeline, I realize the journey that I have to go through. And once you draw that out, the distance comes very easily. But this timeline thing is very important, right? Some students don't need the timeline to visualize, but most students do better when they draw it out to visualize the diagram. So
Feels
these
like
are the three,
like the most crucial part of like visualizing that question, correct?
yes, yeah. But I do have
Okay.
some students that can answer the question without the visualization, which is great, right? But a safer method to me is to draw it out so that you can see for yourself. When you're solving, you can see. When you're checking your answer, you can see, right? So, and also a lot of times I tell my students, when you do your working, it has to make sense. Meaning to say, if maybe I walk towards my door, I stop at the 3-second mark. I turn, I walk back towards my original position at the 5-second mark. My displacement has to go down because I'm now moving towards my original position. I'm nearer. So if your calculation shows that, oh, how come I turn and move towards my origin, but my displacement still goes up? Something is wrong already, right? Because now you're moving towards the original position. So your displacement can't be going up, it has to come down, right? So that's things that you can look out for when you're doing calculation. So these are the three main trickiest topics in AMF, I would say. Some students, or rather most students, think that differentiation is trickier. But the applications for differentiation is not as complex and it's not as tricky because it's very straightforward. The working is very long, but there are not much tricks and ways that they can trick a student. So I would say kinematics, integration, and trigo are the trickiest topics in AMF.
Thanks, teacher Clarence, for bringing us through that. I feel like I completely forgot everything that I learned back then. So this is like a refresher for me. But anyway, we're going to continue talking about a lot more important things. Like, for example, like common mistakes in AMF and like how exactly we're going to avoid that. And like also stay tuned for the very ending where we're going to talk about the last few things that you need to remember and keep in your brain before we go back into your exam. So for now, let's hop to the commercial break and we'll see you guys in the second half of the podcast.
I hope you have been enjoying the contents of the podcast so far. If you want to find out more about the latest study tips and exam strategies, do check out my free ebook that you can download on our website. Additionally, if you are curious about how OVERMUGGED classes are like, feel free to join us for a free trial lesson anytime. Back to the podcast.
All right, welcome back everybody after the commercial break. Now we're going to go into the second question. A lot of you guys have actually asked us, what are some common mistakes that you need to take note of specifically for AMF chapters so that, you prevent going into the exam and making those exact mistakes. Teacher Clarence, bring us through them.
So first off, the first topic that I'm going to cover, or rather talk about, right, is back to trigo again, right? Because like I said, trigo is a very, very big chapter. And when it comes to solving trigo equations, for example, if I have a sine A equals to half, maybe, right? Then some students start off by doing, sine inverse half. I see the answer in the calculator, that's my final answer, right? That's the first mistake that you can make, which is what most students will do in the exam, right? And that's when they will never get the full marks for that particular question. Because the very first step for solving trigo equations is always looking out for the basic acute angle. Right? The basic acute angle is basically this angle that is between the diagonal and the horizontal line. And as I mentioned before, there is more than one answer. So there is more than one answer pertaining to that particular question. And you are to use the basic acute angle to give me the multiple answers. The calculator will not give you two answers. Meaning to say, you sine inverse half, you're not going to see the possible solutions. Right? You are to find them on your own. So the moment you do the sine inverse and give me the answer for A, that's the end. Because you are only going to give me the answer. Which is why I always tell my students, no matter what it is, no matter how simple the equation looks, no matter how complex the equation looks, your very first step is to find for me the basic acute angle. And from there, you can apply every concept that you learn, the ASTC, which what I tell my students is all science teacher crazy, right? That's the easiest way to remember. And from there, once you have the basic acute angle, you are able to find all the solutions easily. So that's the first thing, right? And as I mentioned just now, when it comes to tricky portions of trigo, is that there is a very big range given by a question. So if now the question is not just about x, maybe I'll be asking you, if sine x plus 20 is equals to 1/3, what's the value for x, right? So now the subject in this question is about x plus 20. It's not about x anymore. But the range given to you will be about x. So what the question has provided, you remember this?
This kind of question. Okay, continue.
Yeah, it's very common, right? So the question will give you about x. You are solving for x plus 2. So what students will forget is to find the new range, which can potentially add one solution or deduct one solution.
I know what you're talking about. Okay, continue.
Right? So if you don't find a new range, you might potentially miss out on a solution, or you might potentially include a solution that shouldn't be there. Right? Then from there, of course, you can't get the full marks again. Right? And the last thing that I want to talk about, the common mistakes, right, is what I covered just now, right? Why is it tricky? Why is sugar ratio tricky? Because students like to use the calculator. That's one, right? And second thing is when it comes to finding the ratios, right? Because like I said, I'm going to give you like maybe sine A equals to 3 over 5. So sine is so it's opposite over hypotenuse. So you will get the opposite, you will get a hypotenuse. But in a triangle, there is always the opposite, hypotenuse, and adjacent, right? So students will have to find adjacent on their own based on the information given. But what students forget at times is the quadrants that I lie in determines whether my adjacent is positive or negative. And once you forget the sign, everything will be wrong already.
Oh no.
So that's why you have to look out for the quadrant, whether it's positive or whether it's negative. And that is one very common mistake. So typically for a question like this, maybe 2 to 4 marks, the moment your length is wrong, all your ratios will be wrong. So you might potentially be losing out on 2 to 4 marks. Yeah, so that's the first one. Second one, we go back to Sec 3, discriminant, right? Now, discriminant is usually the first chapter you learn in Sec 3 AMF, right? And the way question is phrased is very important. There's 2 ways the question can be phrased. First one is find the range, meaning to say, find the range whereby there are no real roots. That's the first one. Second one is so that there are no real roots, right? It may seem very similar, but it's 2 very different things. The first one, the keyword here is find the range when I have no real roots. Means it's a fact that I have no real roots. I just need to find when does it happen. The second question is show that there are no real roots. So I don't know whether there are no real roots or not. My job is to prove. And that's when students make the mistake of assuming that there are no real roots. But you must remember, your job is to prove, not to assume. There are 2 very different things.
Oh,
right?
damn.
So your presentation is very important. Like I vividly remember this when I was doing this in Sec 3, right? My first exam on this discriminant thing. My presentation, when it was a show question, I straight away tell the teacher, oh, my discriminant is more than 0. But my teacher told me, your job is to show. Now you're telling me with no evidence that my discriminant is more than 0. That's not how it works, right? I got straight 0 for that question. Right? So that's when I realized the keyword in this question is very important. And students always get confused with these 2 because they will think that, oh, when I ask to show, I can just say that, oh, it's more than 0. But you need to provide the evidence. So that's the tricky part. And then, of course, most students make the mistake of the presentation for this particular chapter. So it's very, very common for students to lose out on discriminant, even though it's a Sec 3 chapter, right? And of course, next one, when it comes to differentiation, right? So this is something that I've been emphasizing to my class for the longest time, is that differentiation has different formulas, right? There are products, there are quotients, there are chain rule, whatsoever. So when you see a fraction, students will think that it's a quotient rule, because quotient rule means you apply it to a fraction, right? But what I have told them from the beginning is that you only apply quotient rule when the numerator and the denominator is an unknown, meaning to say there's an x in it, right? And if there is no x in it, if it's just a constant, like maybe 2 over x, right? 2 is a constant, x is my unknown. Your fraction can now be simplified into your negative index. Meaning to say, if I want to write 2 over x, instead of doing quotient rule, I can rewrite into 2x to the power of negative 1. So now I went from a fraction to a non-fraction, right? And the moment, right? I think you remember what I'm trying to say, right?
Oh my god, yeah, I know what you're talking about now. Okay, continue.
Something like that, right? And the moment you have a fraction, I'm not saying that you can't differentiate using quotient rule, you can. But most students that I see make mistake when they're doing quotient rule. And that's the thing. Which is why from day one, I've been saying convert it into chain rule if possible, because chain rule is much easier, right? That's the first thing. Then of course, second thing about differentiation is when you're asked to differentiate ln, right? the question can look very, very complex. But I always tell my students, or rather what students need to always do to make their life easy when it comes to differentiation, is to simplify the logarithm. So we learn log in Sec 3, right? So whatever we learn there can be applied now in Sec 4. So what students always do is they don't simplify. Then of course, when you don't simplify, the equation looks complex. When the equation looks complex, chances are you will probably make a careless mistake. So what students must do, or rather what I encourage them to do, is to always simplify first before you start a differentiation, right? It makes your life way easier. Then of course, there are a lot of topics that students make common mistakes on, right? But today I'm just going to cover 5. So I already covered 3, right? So 2 more to go. Your binomial theorem, right? Once again, Sec 3 topic. A very common question that they like to ask requires the use of general term, right? So when it comes to general term, a lot of students don't simplify the general term, which means once I do my general term, I have an x power r in front, I have an x power 2 minus r at the back. A lot of students will not simplify, which means they don't combine the x together. So you will have an x in front, you have an x behind. And then chances are they will choose the one at the back because they just wrote it down, right? And then from there, everything is wrong because it's not the correct general term. You simplify first before you do it, right? And another common mistake that a lot of my Sec 3s now deal with, right, and also potentially Sec 4, when I go through binomial with them, is that if I see a fraction, right, like for example, 1 over 2x, my x is in the denominator. To them, when I combine together, they will think that, oh, it's x power 1. But it's not the case. Because when you're in the denominator, you're not positive power anymore. You are negative power.
Yeah.
It should be x power negative 1. But when they put it in the denominator, right, they will think that it's positive 1. Then, of course, everything will be wrong from there. Which is why my trick to binomial is always to simplify first, such that you can see very clearly what is the power for x, what is my coefficient. It makes everything a lot easier for binomial. Yeah. And of course, the last one is coordinate geometry, right? Coordinate geometry to some is the easiest chapter, which I don't deny, right? It's really one of the easiest chapters in AMF. But the problem is when I give you a ratio, like for example, I tell you AB is 2 times of BC. You have to find the coordinates of C, right? And what students will do is, I know the length of AB, like for example, oh, maybe AB is 10 units. And if it's twice of BC, means BC has to be 5 units, right? So they will use the length to find the coordinates of C. Because to them is, I know the coordinates of B, I know the length of BC, I can find the coordinates of C from there. But what they are forgetting is that when you want to find the coordinates of C, there is 2 unknowns, right? The x coordinate and the y coordinate. So you have 2 unknowns, but you only have 1 equation. It is impossible to solve 2 unknowns with 1 equation. And that's what students always do. Yeah, so I always tell my students, you must always remember, if the question wants 2 unknowns, you will need to form 2 equations. If you want to form 2 equations, you need 2 information from the question. If not, you can't form the 2 equations, right? So this is the common mistake that students always do, right? They always use the length to find the coordinates when I have 2 unknowns. It is impossible. Yeah.
Dang.
So of course, is there a way to solve this easier? There is, right? You have to visualize the diagram, draw it out using simple concepts like proportions and ratios. That is the easiest method. Do you want me to illustrate how to solve?
Wait. How what, sorry?
Do you want me to illustrate how to solve?
Wow. If you can go ahead, you can try. I see whether I can understand or not.
So, for example, just now the example I say, right? AB is twice the length of BC.
Okay.
Right? So, the distance I travel from A to B is 2 parts. Right? So now going back to primary school, right? 2 parts and 1 part.
Yeah, that one I can
so
do.
from A to B, I'm traveling 2 parts.
Mm-mm-mm.
From B to C, I'm traveling 1 part.
Mm.
Because I'm 2 times, right? So now if I tell you, from A to B, my x changed by 4 units. So 2 parts is 4 units.
Okay.
Right? Then 1 part will therefore be?
I don't know, you're asking me. I cannot think on the spot.
If 2 parts is 4 units, 1 part will be 2, exactly.
Correct.
So means from B to C, my x will change by 2.
2.
Right? Because you already concluded, 1 part is 2 units. And since from B to C is one part, I'm moving by 2 units.
Well, this is the first
So you
podcast
apply-
that I got questioned and check whether I'm listening. I damn scared, yeah.
Then you apply the same concept for Y, right? So if possible, maybe we include a diagram later for you to see. That's easier. But essentially, it's all about parts and units. Yeah. So these are the rough common mistakes that students make in AMF. The rest, things like careless mistakes, it's very hard to prevent, right? Unless you can go back and really check through every line, which some students don't have the time to do so in the exam. But one tip that I have for all of you though, right, is that when it comes to partial fractions, which is another chapter in AMF, right, it's one of the easiest, but the way students do it, because partial fractions can be quite big, it can be 5 to 6 marks. And what students forget is that what I'm doing in partial fractions is I'm changing from a complex looking fraction to maybe a few simpler fractions. Do you remember what's that?
No, I have no idea.
Okay.
You can continue.
Okay, so basically I'm just writing from one complex looking fraction to 3 simpler looking fractions. So I'm just simplifying. I'm just writing it in another form. When I'm writing it in another form, what students forget is that the value doesn't change. So when they do that, right, they don't even check whether my value changed or not. So I always tell my students, right, if you do a partial fractions question, you want to check whether your answer is correct or not, right? They don't do that. Some of them don't listen. Like I tell this to my students. They don't listen. They think that my partial fractions answer looks so beautiful, whole number looks so nice. They think it's correct. End up it's wrong, right? Because they just refuse to check. So when I say check, meaning to say I have an original question, right? You sub in an x value in. Let's say you get 1/5. So meaning to say my original question is 1/5. Since the concept here is the value doesn't change, your final answer should also give you 1/5.
Okay.
If it doesn't give you 1/5, means the value has changed, means the answer is wrong. Right? So students don't think that is important, but in AMF, there is really not a lot of chapters that you can check like this, right? The only way you can check is to really go through every step. But you don't have the time to do that because every question is about what? 10, 15 lines of working. You can't possibly do that, right? So when you can have an opportunity like this to check for partial fractions, you have to do it. Yeah.
And speaking of checking also and making sure that you're prepared for the exam, right? You know, in that last moment where students are kind of panicking, right outside, you're standing right outside the classroom and the teacher's like, okay, you can come in 5 minutes, get ready. You will just completely go into a panic. Is there some way that you can recall certain last minute important things before you step in, or certain formulas that they need to have at the front of their mind? Any of those?
So what I think students must know before you step into the exam hall, right? I'm not sure whether the 10 minutes before exam hall can really make you remember all this new content. So I would say maybe you start remembering and applying from now on so that it becomes a habit, right? It becomes a muscle memory to you. But the first one that you must know is trigo graphs, right? So back to trigo again, right? Everything is about trigo because it's really a big chapter. So the thing for trigo graphs is a lot of students memorize the shape. Not wrong, you must memorize the shape. But when the equation changes, the shape changes, the value changes. So instead of using memorization, one thing that I always tell every kid that comes to me for trigo, right, for help, is that your first step is to identify the period, meaning to say how long does it take for you to complete one graph. Once you have that, you break it down into 5 parts. You get the 5 values of x. You can sub into the question to get the value of y. So instead of memorizing the shapes and the values itself, you give me the 5x value. So for example, 0, 30, 60, 90, 120, for example, right? My equation is y equals to sine 2x. If I know the value of x, I type calculator, I get the value of y. I can plot on the graph. You plot the 5 points, you draw a curve that outlines this, that passes through these 5 points, right? That's the final answer. So I don't need to memorize. I just need to remember that it's a curve. And that's what I always tell my students. You give me the 5 points already. At least draw a curve. Don't give me a straight line. That's the thing you need to remember. Yeah. So that's the first thing, right? Because a lot of students that I know, they like to memorize. Nothing wrong. If you are able to memorize and apply it correctly 100% of the time, you go ahead, right? But if you can't, the best way is to find out these 5 points in a period and then type in the calculator to give you the value. right? Then of course, second thing is back to graphs again, but now it's a different chapter, logarithm and exponential graphs.
This is the worst. I used to hate
Yeah.
it.
Because it's not something that you usually see. Usually you see just algebraic graph, cubic graph, quadratic graph, whatsoever. So when it comes to log and exponential graphs, same thing. Students like to memorize, which I have nothing against. It's just that as a student myself last time, right, I hated memorizing. I don't memorize anything. Because I feel like I'll just forget. Right? So I keep thinking of ways to help myself in an exam without memorizing. And now I'm sharing it to my students in class, right? Is that when you draw a log and exponential graph, you just need to remember to find the asymptote. That's the most important thing. So in case you're wondering what's an asymptote, right? It's a line that you go very close to, but you don't touch.
Oh, yes, I do remember briefly.
Right? So once you know where's the asymptote, you know your graph cannot touch that line. You know your graph cannot cross that line. You will have that bit of logic in you to know how to draw the shape really. Because you know you can't cross the line. Right? So you can't be drawing a graph that will eventually cross the line. You know that you can go very close to it, but you won't touch. Right? So with that, you don't need to memorize the shape. You don't need to memorize where's the asymptote. Because once you identify the asymptote on your own, you will then be able to plot the graph on your own. But the thing is, how do I identify the asymptote? Right? Because like I said, it's log and exponential graph. Right? So one thing that I need all students to know is that I cannot log 0. I cannot log a negative number. Once you know that, for example, my equation is y equals to log x. I'm applying the log to x. Based on my concept, I can't log a negative and 0, right? So that means x can't be 0, x can't be negative. That is your asymptote.
Oh, okay, I remember briefly. Oh my goodness, this is horrible.
So your asymptote is always derived by your mathematical knowledge, right? That you can't log a negative, you can't log a 0. That's the easiest way to identify the asymptote for you, right? And once you know that, I am quite confident in all of the students that they can plot the graph in. Yeah. Then, of course, you need to know how to solve a quadratic inequality. So why do I say that? I mean, it's a Sec 3 topic, right? It may seem very simple to some students, but you will use that in differentiation. So it's not just appearing in one chapter, it will appear in differentiation as well, right? So solving quadratic inequalities to some students is like solving a quadratic equation. Not wrong, right? But the main difference is instead of equals to 0, it's more than 0 or it's less than 0, right? And there are just 3 steps to answer this question, which I've shared on our TikTok channel before, right? There's a video on it. So I think that's the most important thing. You need to minimally know how to do that. If not, you can't answer a Sec 3 topic question on that. You can't answer differentiation, right? So you need to know how to solve a quadratic inequality. Then, of course, just now I mentioned partial fractions, how to check, right? Before that, there are only 3 formulas to memorize in partial fractions. You need to memorize that. Like, I know it sucks to memorize stuff, but you just have to memorize the 3 formulas to split your partial fractions up. That's the bare minimum that you can do. The rest comes to you very easily. And of course, back to trigo, right? There is this thing called special angles, which you are supposed to know, right? So, like for example, if now I say sin x equals to 0, for example, they ask you for the value of x. Sure, you can press the calculator. You press the calculator, you will just see 0. To some students, oh, I only got one answer, 0. But in fact, there are 3 solutions. So if you don't remember that, chances are you will not be able to answer a question like that. And of course, my trick to all my students is remember how the graph looks like. Because if you remember how a sine graph looks like, you are able to pinpoint out where are the portions whereby I'm equals to 0. You will then remember the answers for x instead of relying on the calculator. Yeah. So that's what you need to minimally know. And of course, the last thing that you need to know as well, right, when it comes to this chapter called equations of circles. So the thing about equations of circles is usually I'll be given the equation. Part A is always about finding the radius or center. So I must learn how to derive the radius and center from the equation, right? There's a formula to do that, right, which students must memorize. But if you can't remember that, right, you can always use complete the square to simplify the equation to identify the center and the radius. Why is this something that I need all students to remember? Because if you don't know the center and the radius, chances are you can't do B and CA.
Because the first
Yeah,
part.
so it's always related. Yeah, it's the first part. And if you just leave it blank, right, definitely zero. You should just give up. It's definitely zero, right? And of course, if you try some other method, you get the coordinates of the center, right? You make use of the center to answer maybe part B, part C. If your working at the back is correct, you will still get ECS marks and will carry forward, right? So you won't get marked down straight away just because your part A is wrong. But if you can't get the center and radius right, then to you, like, your mentality at that point in time, you will be very demoralized. You will think that you can't do the question. Then chances are you just give up. Then the entire question gone.
Gone.
Right? Yeah. Which is why you need to remember and know how to find the center and radius of a circle. Yeah. So these are the things that I think you really have to know. Yeah.
There's a lot of stuff.
I mean, of course, I'm not gonna say that you need to memorize all the formulas for differentiation and integration, right? Because that's a given, right? You don't need me to tell you that, you will know already, right? But things like that are what students think is not important, but it's actually very essential in scoring the A1 for AMF. Yeah. And one last thing, or rather one more thing that I want to talk about, right, is it's not related to like, oh, which formulas I must memorize, what method I must remember, whatsoever. Is that when it comes to a question that has part A and part B, right? So an example I'll give you is part A is trigo identity. Part B is solving of trigo equations. Part A you have to prove, and students hate proving, right? They think it's very difficult. But what I always tell them is, even if the question looks very complex, you start writing something, you will never know what you will get. If you don't write anything down, right, trust me, you will never get it, right?
Fair point.
Because the paper is empty, right? But if you try writing, then you might get the answer. But you must also take into consideration the time that you have. So you can't possibly spend 20 minutes to answer that question, because even if you can't prove part A, it's given to you already. So you know what it's like. You can make use of that to answer part B. And chances are part A is usually lesser marks than part B. So don't throw away your time trying to solve part A when you don't need to. Use the information to solve part B, which has a higher weightage.
Oh, so this is more like exam strategy, right? How do you put your time based on the allocation of marks lah? So basic common sense.
Yeah.
Okay.
Yeah, basically, I don't want students, or rather, I hope students don't give up. Just because the part A can't be done, right? Because I've seen a lot of students, like, part A is a show question, I can't show it, then part B, since I can't do part A, then I can't do part B. But that's not the case, right? And this is something that can be applied to a lot of other chapters, like maybe differentiation, R formula, whatsoever. As long as part A is a show question, you are given the equation itself. Make use of that to answer the behind question. It's fine. Give up the 2 marks to score the 8 marks at the back. It makes perfect sense. Yeah.
Okay, I see. Actually, today we went through quite a lot of honestly damn good tips and tricks, because teacher Clarence really went into the specifics of each chapter. And actually my question to you to end off today's podcast is, what topics are you specifically doing, for July prelim preparation? Are you thinking of certain specific topics that students are struggling with? What exactly is happening in July that we're going to do to prepare students for O-levels?
Okay, so for the July prelim preparation program, right? 4 weeks. The first 2 weeks, we are going to be covering on integration techniques, which means things like the formulas, how to integrate, what to look out for, your definite integrals, things like that. The second lesson will be on the application of integration, area under the curve, and kinematics. And of course, why we are doing that is because we didn't cover that in the June intensive revision. For the June intensive revision, which is currently happening, we are focusing more on the Sec 3 chapters and the Sec 4 first chapter on differentiation, right? So integration, for some schools, right, they haven't finished learning yet in school.
Oh.
Right, so we leave it for July so that it will be a better time where they just learn, and they might need more tips and tricks and a recap of it. Basically, right, so that's for the first 2 lessons.
Prelims lah.
Yeah, correct.
Okay.
And the third lesson for the prelim preparation program will be a mock paper, right? So the mock paper will cover most of the topics that will be tested on for your O-levels. And then the fourth lesson will be used to go through the questions and maybe do more example questions of the kind of questions that students make mistake on.
So it's really
Yeah.
like to bang down on like prelim specific issues, exam questions that help you to get to the point where you're confident to do like a prelim mock paper before you sit for your O levels lah. So it's kind of like
Yeah.
last ditch effort, everything all in kind of program.
Yeah.
Okay, I see. So in that case, right, actually, I'll let teacher Clarence share a little bit more on our Instagram about July prelim preparation program. And for now, we'll wrap today's podcast. And we hope that this episode has been really specific and direct for you guys to know what you're looking out for. We'll definitely attach the questions in our Telegram chats as well. So give us a follow. We'll send you prelim questions that can help you to brush up in the lead up to the whole July prelim preparation period. So with that, hope you guys enjoyed. If you want more of this content, remember to like, share, and subscribe, and tell us what else you'd like to see on our podcast. With that, see you guys in the next episode. Bye.
Bye.